All right. Hopefully, you all have become experts at drawing contour lines and actually probably love it so much that you're drawing contour lines on your own just for fun these days in quarantine. Um, However, today and this week, we're really going to switch a little bit of the focus from you making all the maps and drawing all the lines to actually having maps that are already done for you, already drawn for you, which is nice. And we're going to kind of learn and see how to read those maps with a little more detail than you probably got when you were in high school or middle school. So right now I'm starting us out with this beautiful picture. I'm actually navigating through Google Earth, and it kind of does a good job if you set your settings to, so you can actually follow along with this if you want, if you have Google Earth, but you can change the settings so that it shows this grid structure, and it's one of everybody's favorite things that they ever learned, latitude and longitude. So anyway, in just a second, I'm going to come back to this, but I wanted to show you where all these lines came from. And it's kind of neat because if you slice the Earth in half, either way, you can create lines of latitude and longitude by drawing basically the radius of our little circle that you get when you slice the Earth in half. And you can kind of see it in this picture. And you can pick and choose if you want to use a 15 degrees or 10 degrees or whatever between your little lines. And so you kind of see, if you extend those out to the surface of the Earth, where these lines actually come from. So I wanted you to see that. You really don't need to know much about that, but it's kind of neat to see where the system came from and how they historically kind of put it together. But this one's much more pretty. I just wanted to talk to you about the main ideas here. First of all, the big lines that we all start out with, the equator, that's the one in the middle. And then if you sort of scroll around here, there's another one that goes up and down. You can see the darker yellow line there. It's called the prime meridian. And I'm going to zoom in just a little bit and see how it's labeled there now. And it kind of goes through right about here. And I wanted you to see where the prime meridian is. We all know where the equator is. I mean, it goes through the middle of the Earth that way. We'll look back at that in a few minutes. If you notice where the prime meridian actually is, look at which country it very clearly goes through. And I want you to think about why that might be. And it really goes back into history with who had the first ships and really had to develop maps so that they could better navigate the world that they completely didn't know the full extent of. And so if you look, it kind of goes right up through, and it actually goes through a little town called Greenwich, which I don't think it's going to show unless I zoom into the right spot, but really basically London. And basically they said in history, British Empire, they said, well, we're the ones making these maps and we're the ones developing all this whole system. So we're going to be in the middle of it and we're going to make ourselves the center of the world. And they did. So that's why the prime meridian is set here. Because if you turn this globe at all, look at all these meridians. There's an infinite number of meridians, but they just chose to start right here at this 0 point, which they basically put themselves at. Funny story is, if you look really closely, if you go to their favorite neighbor, France, the prime meridian does go through parts of France, but importantly, if you were to actually go to France and look in some museums, you'll see that the prime meridian actually is not where you see it here, but it actually goes through Paris. So that's kind of neat. They actually kind of said, no, we're the center of the world here, and we want the prime meridian to go through Paris instead. So they actually, there are maps out there that have the prime meridian there, and it's only a few degrees off, obviously. But anyway, so that's what we're looking at here. So I want to kind of zoom back out a little bit here, and we're going to kind of look at what is the special thing that goes on. So you see your prime meridian going all the way down through Europe and then in Africa. What happens when the prime meridian crosses the equator? Well, let's zoom in. Nothing. So basically, maybe you'll see some sharks or some fishies, but really there is nothing special about that location. It's just some water, a lot of ocean water, and I'm guessing it's probably fairly warm because it's so close to the equator, obviously. So anyway, that's kind of a background of the system. So let me just talk about what you need to know. And by the way, I can't not mention, we have some other lines on here. We have the Tropic of Cancer. We have the Tropic of Capricorn. Those are just more of a celestial meteorological thing because the sun is always somewhere overhead in this area. This is called the tropics. So during our summer, the sun kind of comes in and hits over here at the Tropic of Cancer, which is actually pretty close to Texas. And so you see why we might get very hot when the sun's rays are coming down right on that spot. Then as we go into fall, it goes back towards the equator. And then in our winter, which we're coming out of, it ends up here over the Tropic of Capricorn, and they have their summer down there. So that's how that all works, if you ever wanted to know. And so those are cool. The other ones that are pretty neat, we have the Arctic Circle and the Antarctic Circle. And those are where during the summer or winter, you either get 24 hours of light if it's the summer, or 24 hours of darkness if it's the winter, depending on which season you're in. And that is, again, due to where the sun's rays come in. So believe it or not, if we look at the Arctic Circle in, say, June, the sun never sets there. It's pointed so directly toward the sun that the sun is always seemingly up. So anywhere inside that circle, you actually have 24 hours of light. And in the winter, when it's tilted away from the sun, you actually see 24 hours of darkness. Not a very pleasant place to live. So the other thing to notice while we have this zoomed in this area, look at what happens to all the longitude lines, which are the ones that are kind of coming together right where it says 90 degrees north. That's interesting. So what happens if you're standing right here? Well, that's the North Pole, number one, and you're standing on a point where all the longitude lines actually cross each other. And that doesn't happen with the latitude lines, which you see as circles right now. So it's kind of weird how that happens. So that has an implication for later. When we look at our maps that we're about to get into, the longitude lines actually curve on the maps. And if you can see here why, as you go, you can't just say where it says 30 degrees north there, right above the word tropic. You can't just go, all the lines near it don't go straight up. They actually curve toward each other as you go further north. So it's kind of weird, but that's all because we're on a sphere and it's more complicated than you need to worry about. What else can we talk about here? So big picture. Here's the equator again. If you are anywhere where I'm showing you now, up here, all of this, so now the equator is actually the circle around the edge of the circle around the edge of the Earth that you're looking at. That's the equator. Everything I'm looking at right now is the northern hemisphere. So everything above 0 degrees latitude is considered the northern hemisphere. So that includes, if you look at that, the United States, some of South America, a good chunk of Africa, all of Europe, all of Asia. India's in there, Saudi Arabia is in there, Japan is in there, so Hawaii is in there. Everybody is all in the northern hemisphere except most of South America. So that would include like Brazil, parts of Brazil, Chile, Argentina, Southern Africa. So that's South Africa, and there's Madagascar, the island. And then Australia, that is one of the only continents, I guess, that's completely in the southern hemisphere. So that's and there's New Zealand, by the way, so they're in the southern hemisphere. The other one to look at is now if we turn the globe and we start looking at the prime meridian again, which is 0 longitude, look at everybody to the left. So left of basically 0, that includes all of these places. So part of Africa, some of Europe, all of South America, all of North America, and then we get around to the other side of the Earth, and there's another solid line here. Well, what is that? And I wonder if it says it anywhere. I don't know why it doesn't. It's a pretty important line. And I'll just say it if it doesn't label it by itself. It's called the International Date Line, and it's 180 degrees of longitude. So from 0, if you do a half circle around half the Earth, 0, and then you go all the way over, here's 130 west, 40, 50, 60, 170. They're anti-meridian. How about that? That's what they mean by date line. So it gets to 180. When you do half a circle, half a turn, then you've reached a point where now the longitudes start going back down. So 170, 160, 150, and all the way back to 0. So basically what that means is everybody who's on this side, I didn't mean to drop that pin, everybody who's on this side is in the Western hemisphere. So west is everybody over here. And then east is everybody over here. So in the Eastern hemisphere, we have most of Africa, almost actually all of Asia. India is in the Eastern hemisphere, and Australia is in the Eastern hemisphere. What happens is, the Earth is constantly rotating. And if you look at it from above, it actually rotates like this, which is counterclockwise. So let me do that again. That way, that way, that way. If you switch down, so if you switch it to the other hemisphere, it actually looks like it's rotating clockwise, which is weird. But that's another little mind illusion that is created by the rotation of the Earth. So basically, just trying to show you that it's based on which line you're looking at, whether you're north, south, east, or west, and everybody has a latitude and a longitude. So let's zoom in and look at where Dallas is. So let's kind of find that, keep it right side up here. And if you look around, we have some lines with the letter N printed on them. That's the latitude line. So 31, 32, and 33 north. So Dallas is between 32 and 33 degrees north. And then longitude-wise, we're right around, literally almost right between Dallas and Fort Worth. It's 97 degrees west. So you all see that, right? And so the thing is, if you look at everybody in the United States, if I start moving around, what if we went all the way up into lovely Colorado? Well, they're north and their longitudes are west. What if I go over to New York City? Well, they're north and their longitudes are west as well. So what I'm kind of getting at here, what if I went all the way to Canada? Let's try one other place. Saskatchewan, beautiful area. Okay. They're north of the equator further than us, and then they're west. So the whole United States is in the northern hemisphere, and it's also in the western hemisphere. So what I want you to take away from that is, what if I'm driving from North Dakota, and then I drive all the way down back to Dallas? I drove south, but did I leave the northern hemisphere? No. Did I leave the western hemisphere? No. The only way that's going to happen is if you get on a very, very long flight and you get out of Dodge and you go way across the Atlantic and you land over maybe in Dubai, down over here. Now you've jumped, well, it looks like you've jumped, you're still in, there it is right there, sorry. You're still in the northern hemisphere, but you've jumped over to the eastern hemisphere. If you want to go to the southern hemisphere, do this. Great, great place. Check this out. It's almost right on the date line, actually. Fiji, beautiful island. Now you've taken a very long flight, probably an expensive one. You've gone now to the southern hemisphere and you're now in the eastern hemisphere, barely. Okay, so just kind of getting you some perspective on that whole globe and the latitude longitude system. One of the things I want to kind of zoom in on here, and we'll go back to Dallas because it's easy to see. I don't like that they put those interstates on there. It gets a little confusing, but so listen to this. Oh, I zoomed a little too far. I don't want you to see that yet. All right, there we go. So look at the difference of 32 degrees. So right in the center of the screen, I'm wobbling it so you can see it. And then 33 degrees. That's only 1 degree of longitude, or latitude, sorry. So how far is that? Literally, you're going from south of Fort Worth and Dallas all the way to the other side up north. So 1 degree of latitude is actually a lot. So as we zoom in further, you'll see it puts more grid lines on there. And now you start to see right next to the 32 and 33 degree numbers, you see a little other thing with a little quote mark after it. Says this, for example, right in the middle of the screen, it says 32 degrees, 30, and has a little quote and then end. So what we're doing is we're actually dividing a full degree of latitude down into smaller little bits, and they call those minutes. So as you zoom in further, you see that there's 3220, 3225, 3230, 3235, and so on and so on. And then when you get to 55, it switches to, when you get to 60 minutes, it actually starts over again, and now you're going 5, 10, 15. So there are 60 minutes in a degree of latitude. And the same will go for longitude. So if you kind of look at some of these numbers and we go out from, let's say, start at Fort Worth and head over, I think that line, which one goes right between us and Dallas, or Dallas and Fort Worth rather, it is, find the line, 97 west. Okay, so it's right in the middle of the screen. As you head over, you can see the little 97s have minutes attached as well, and they're the same. So there's 60 minutes in each degree of longitude as well. So just some more stuff you might see, because the minutes, you know, a whole degree, and you can literally skip across an entire city. So they needed to divide it up to make locations have more specific coordinates. So that way, like when I want to know, okay, well, what's Irving, which is where Northlake College is, it looks like it's about 32 degrees and 49 minutes north latitude, and then 96 degrees, 57 minutes west longitude. So you can get pretty specific information if you use those coordinates and you use the minutes and the seconds. So that sums it up. By the way, just I guess maybe just for sort of trivia, to go from 30, let's see, we want to go from 32 degrees to 33 degrees and skip across Dallas Fort Worth. That's a distance of about 70 miles. So it is a long distance, which is why we needed to divide up that degree into some smaller little pieces. But we never show all those lines, because that would be just ridiculous to see all the minute lines and the second lines on there, and it would make the map look messy. So that's just a little brief history of latitude and longitude. Now, if you haven't yet, make sure you download the Irving quadrangle map, which is in our eCampus folder here, because we're going to start looking at a more detailed close-up view of where we all live.